Components of vectors. Any vector can be built with two perpendicular components like this. So A in this case equals vector AX plus vector AY. The two components. There are unlimited ways to determine AX and AY. What does that mean? Because you can build AX and AY this way too. So there are unlimited ways to build the vector A. A equals to AX plus AY. AX is a vector in the X direction, and its magnitude is A cosine theta. The direction is in the X direction. AY is a vector in the Y direction. Its magnitude is A sine theta. But pay attention, in this case, A cosine and A sine is when theta is the angle swept out from 0 degrees. Sometimes if you are given this theta, then AX has to be sine because that's opposite of theta. AY would be adjacent. So pay attention to how theta is given to you when you determine AX and AY. So AX and AY are called components of vector A. Any vector can be decomposed into X and Y components. The sign of components depends on theta or quadrant. In this case, when theta is less than 180, greater than 90, or the vector is in second quadrant, you know Y is positive, X component is negative. When a vector is in third quadrant, both the X and Y are negative. Fourth, X is positive, Y is negative. And sometimes you have to pay attention of how X and Y is given. In this case, both X and Y are positive. And in the Y direction actually is cosine, because it's adjacent to your beta, and X direction is sine because it's opposite of your angle. Vector components on the incline. On the incline, we usually have X parallel to the incline and Y is perpendicular to the incline. So we have to resolve this W. This is W right here. The perpendicular component is negative W cosine alpha. Negative means it's on the negative side of your Y, and parallel is on the negative side of your X. But if you have your X downward, then this would become positive. Let's do an example. What are X and Y components of vector D and vector E? They are given vectors. So as you can see, D is in fourth quadrant, so X should be positive and Y is negative. You can use alpha as negative, it's give you automatically, but if you use just a positive 45 degrees, you have to pay attention. dy should be negative because it's in fourth quadrant. In this case, Ex is positive, Ey also should be positive, but Y should be cosine because again, Y side is adjacent to beta. Adjacent is cosine. X is opposite to beta, so X should be sine. So here is how you find X and Y. Vector calculation using components. So here is R equals A plus B. How do I find R? A and B are not perpendicular to each other. So to find R, I want you to pay attention to this big triangle, right? So R squared actually equals Rx squared plus Ry squared. How do I find Rx? As you can see from this diagram, Rx equals to Ax plus Bx. So Ry, this side, equals to Ay plus By. So first we have to find components of A and B. We have to decompose it. Ax and Ay. Remember, this only works, again, when theta is sweeping out from your X, positive X or 0. Next, you have to add components together to find Rx and Ry. Finally, not finally, next step is to find the magnitude using Pythagorean theorem. And finally, to find the direction, you have to use inverse tan. Pay attention to the directions or components of Rx and Ry. So when I find theta, I just use the number, is not the sign. So that's why I put absolute value here. And to determine the angle, you have to see what are the signs of Rx and Ry. Next one, multiplying vector by scalar. When you multiply by the positive number, you change the magnitude, okay, but the direction is the same. For example, d equals to 2a, d is twice as long as a, and that means dx is 2ax, dy equals 2ay. Multiply a vector by a negative scalar, you also change the magnitude, the length, but the direction is reversed. Okay, so dx is negative 3ax, dy is negative 3ay. Let's take a look at another example. So 3 players are brought to the center of a large flat field. Each is given a meter stick, a compass, a calculator, a shovel, and following 3 displacement, 3 vectors A, B, and C. The 3 displacement will lead to a point where the keys to a new Porsche are buried. 2 players start measuring immediately, but the winner first calculates where to go, then what does she calculate? As you can see, this vector R is the vector sum of A plus B plus C. To add them together, first you need to find what A is. A is in first quadrant, so we know AX equals A sine theta. Y is sine because theta is given to you with the Y components. So X is the opposite, so that's why it's sine. Y is adjacent, that's why AY is a cosine theta. Vector B is in third quadrant, so both X and Y should be negative. Since the angle is with the X component, with the X axis, so BX is negative B cosine theta and BY is negative B sine theta. C, on the other hand, is parallel to negative Y axis, so C has no X component and the Y component should be negative. So next one is to find what's AX, AY, what's BX, BY, what's CX and CY. And then you add everything together, use Pythagorean theorem to find an angle. You use only the numbers RY over RX. So you have 51.2 degrees. Where is 51.2 degrees? Here is 51.2 degrees. So how do you describe the direction? The direction, we know the resultant has a magnitude of 12.7 meters. What is the direction? Direction usually you'll have with positive east, positive 0 degree. So over here is 51.2. From 0, positive x to here would be 128.8. These two together, add together equals 180. So 128.8 equals to 180 minus 51.2 degrees. Another way to determine the direction is from east, north, west, or south, because the angle is sweeping from the west. So it's off west. Which direction you're going? You're going to the north. So it's 51.2 degrees north of west. Another example. After an airplane takes off, it travels 10 kilometers west, 8.7 kilometers north, and 2.1 kilometers up. How far is it from the takeoff point? Now you have 3 vectors. So basically you have this vector, that's west, this is north, then this one is up. To add 3 vectors, you ended up over here, you simply use Pythagorean theorem, add all 3 together. You have 13.7 kilometers. Test your understanding. 2 vectors A and B both lie in the xy plane. Is it possible for A to have the same magnitude as B but different components? Let's take a look. So here's x and y. These 2 components have the same magnitude, but their components are different, so it is possible. Is it possible for A have the same component as B but different magnitude? If AX equals to BX, AY equals to BY, they must have the same magnitude, so it's not possible for that. And that's it for today. Thanks for watching.